Hello, today we're going to be talking about proper water supply and exhaust connections to your water break dynamometer. However, before we get into the actual connections, in order to optimize the full capabilities of your dyno, there are three main water factors that need to be considered. They are clean, cool, and regulated. So let's start with clean. Local water quality is an important factor. PowerTest recommends the following when it comes to water quality. All dyno locations around the world will have different water qualities, hardnesses, minerals, and so on. It is a best practice to consult a local water professional and follow their water treatment recommendations based on your location. We also recommend that you run your dyno water supply through a filtration system. We can provide water filter housings and will work with you to configure your application. Again, filter systems can vary based on the location, so if you have any questions, please contact us. Next, let's talk about cool. I'll be referencing the 45X dynamometer in the following examples, but this example covers most of our water break dynos. Consult your dynamometer's owner's manual just to be sure. So on the 45X, we recommend a water supply temperature of 85 degrees Fahrenheit, which equates to 30 degrees Celsius. Now, just to be clear, this recommendation is the highest temperature that should ever be going into your dyno to maintain its full capabilities. Water break dynamometers ultimately heat the water as they absorb horsepower being produced, so the cooler the water supply, the better. Which brings us to regulate. Whether you're running a closed recirculation system with a cooling tower, or a glycol system, or running off a fresh water supply, pressure and adequate flow are very important factors. Supply pumps come in various sizes, and they are sized based on your specific application. Ideally, you want the supply pressure to be between 45 and 65 psi, or 3 to 4 bar max going into the dyno. So for water pressure, we want a higher pressure before the water reg system, so we can regulate that down to 65 psi or 4 bar. We also require roughly 6 GPM or 23 liters per minute of flow for every 100 horsepower being tested. These are rough guidelines, so please contact us if you have any questions. So let's take a look at the common water circuit. Here's the dyno supply pump. And notice, after the pump, we recommend a Y strainer to filter out any large particles that could have somehow made it through the pump filtration system. Then water flows into an accumulator, which takes up small spikes in the water flow and smooths them out. Next, water flows into the pressure regulator. Ideally, we recommend customers install pressure gauges before and after the regulator. With these pressure gauges installed, you will be able to read the supply pressure from the pump and the supply pressure to the dyno to verify the regulator is actually regulating down your supply pressure. These gauges can also help with any future troubleshooting that may come up. So let's cover the actual water connections to your dyno now. If you ordered a dyno-mounted water pressure regulation system from PowerTest, you simply connect the water supply connection to the regulation system. If you are making a hose connection to the dyno, it is essential that this connection is properly sized and does not side load the dynamometer. To help explain side loading, I want you to imagine that the load cell and discharge lines are not attached to the dyno. The carcass is actually free to spin. We do not want the hose connection to force the dyno to one side or the other. This is known as side loading, and this force will affect the load cell reading when the load cell is connected. The water return or discharge connections from the dynamometer are equally as important as the inlet. Typically, dyno outlets are open air gravity drains, and it is common to size the outlet 2 times the size of the water inlet. So as an example, you have a 3-inch dynamometer inlet, you would need a 6-inch dynamometer outlet. If you have a vented dyno, the outlet connections are already sized accordingly and can be hard plumbed since the venting takes care of the gravity drain within the subbase. So in closing, it is important to have a clean, cool, regulated water supply to your dyno, coupled with an appropriate water return connection. to ensure you have a reliable, low-maintenance, repeatable testing environment. As I've said several times during this tech tip, please contact us with any questions you may have, and I hope you have a great day.